Hi everyone, today I'm going to be talking about homework number 15, and this is out of section 8.6, which was all about the natural log or the ln function. Alright, so for your first set of questions, it just asks you to find the value of y for the given value of x. So I'm going to go ahead and just do an example that's kind of similar to question 10, like the one you guys are doing. So I'll just set up some function, let's say 5 plus, and we'll say, 4 times the natural log of x. And then it says solve. Let's solve for x equals, let's say, 3.2. Alright, so seeing as I gave you an x value for this problem, we're just going to plug that right in for x. That's going to be the first thing we do. So my function's now going to look like y equals 5 plus 4 ln of 3.2, the x value that I gave you. So at this point, we got to follow our order of operations. I see a natural log, which has parentheses inside of it, so we're going to start there. So I'm going to do the natural log of 3.2, and that's going to get me about 1.16. So I'll say y equals 5 plus 4 times 1.16. Okay, now I'm just going to do my multiplication here of 4 times the number we just calculated. When I do that, I'll get y equals 5 plus 4.65-ish. And then, obviously, last but not least, we just add 5 to this number. And I'll get my answer of y equals 9.65. Alright, so your next set of problems has you guys doing 14, 15, 16, and 22. So out of this, I'm going to go ahead and do question 17, kind of show you how to walk through these problems. So for these, it just says solve each equation. So for our first one, for the one that I'm doing, I've got natural log of 2m plus 3 equals 8. So remember from class, the opposite of a logarithm is an exponential, and the opposite of the natural log is the natural exponent. So I'm just going to turn the left side into just one big old exponent here, which has a base of e, and the entire left side here is an exponent. Okay, so remember with equations, whatever you do to one side, you better do to the other side. So on the right side, I'm going to have e raised to the 8th power. So since these are inverses, these undo each other. So on the left side, I'm just left with what was inside those parentheses, or 2m plus 3. And on the right side, I have e to the 8th power. So remember, e is just a number, so I'm going to go ahead and actually calculate the right side. So when I do second ln, which gets me e, I'm going to raise that to the 8th power, and I get about 2,980.95. So I have 2m plus 3 equals that number that I just calculated. And we're actually going to round up and call this 0.96 here. So at this point, now it's just solving a simple two-step equation. Subtract 3 from each side. That's going to leave me with 2m on the left side, and on the right side, I'm going to be left with 2,977.96, and then I just divide each side by 2. And when I do that, I get about 1,488.98. And there's my final answer. Alright, for your next set of problems, we're basically going to be doing the opposite of what we just did. So here I have you guys doing 23 through 26, so why don't I just go ahead and do question 27 here. So again, all we're doing here is solving equations. But now, this time I gave you an exponential equation where the base is the natural exponent, or e. So, just like we did last problem, I need to get rid of this exponent, and remember the opposite of an exponent is a log. So what we're going to do is take the natural log of each side. Okay, so when I do this, remember natural log, natural exponent, they undo each other or cancel each other out. So on the left side, I'm left with 2x. On the right side, I've got the natural log of 12. So on the right side, this is just a number. I can go ahead and solve this thing. So when I plug into my calculator, natural log of 12, I'm left with 2x on the left side, and on the right side, I have about 2.48. And then obviously to finish this one off, we're going to divide each side by 2, and I get x equals about 1.24. Alright, so your next two sections are titled, the first one is investing, and the second section is savings. So I know these look like two different sections, but they're actually the same kind of problem. So I'm just going to kind of work out of the savings ones, because I didn't give you every single one of them, but this should also help you solve 29, and then 47, 51, and 54. So let's just go ahead and do 48 out of that table section. So in 48, it says we have an investment of $500, or our principal is $500. Then tells us we have a 5% interest rate, so R, and we're not going to use 5 here, we're going to use the decimal form, so 0.05. Says we're compounded continuously, and we need to figure out how long it's going to be until we get different amounts of money. On question 48, it says that we're waiting until our account, or A, has $700 in it. So for these problems, all we're going to do is set up the equation A equals PE to the RT, or our PERT equation, and I've given you 3 of the 4 variables, so we can actually go ahead and solve this thing. So on what I've been given in question 48, I know that 700 is equal to 500 E to the RT. So in here, we're trying to figure out how much time it's going to take our account to get to $700. So what we're going to do is just kind of walk through solving this problem. So here, remember, I need to get my exponent by itself. So to do that, I need to get rid of this 500. So the opposite of multiplying is dividing, so that's how I'm going to undo that 500. Then I'm just going to make sure I do that to the other side as well. So on the left side, I have 700 divided by 500, and I get about 1.4. On the right side, I'm just left with my E to the 0.05 T. So now I've just got my exponent on my right side, so to undo an exponential, the natural exponent, we're going to take the natural log of each side. So on the left side, this is just a number, so I'll take the natural log of 1.4, and I'm left with about 0.336 on the left side. On the right side, natural log and E cancel each other out, and I'm left with 0.05 T. So now this is just a simple one-step equation. On the right side, I'm multiplying, so to undo that, I'm just going to divide by 0.05. Make sure that we do that on both sides. So when I take my left side and divide it by 0.05, I'm left with a T value of about 6.7 years.